This is 34-5. We're going to be taking a look at trig graphs, and we're going to specifically examine cosecant and secant functions. So we're going to graph cosecant and secant functions. Now this is kind of like, I would say, the parent graph of what secant and cosecant functions look like. But the more important thing is to look at this dotted image. That looks like a sine graph, and that looks like a cosine graph. Now the thing about that is the way that we can construct our cosecant and secant graphs is from the sine or cosine graph, and we use that information there to be able to create our secant graph. And so where it crossed the center line here is where I drew asymptotes, and then at the highest points where it would normally go to the amplitude, that's where I draw these parabolic looking things. They're not parabolas, but they look like it, and they're moving away from the center line. Crosses the center line here and here. There's those parabolic looking things moving away from the center line. Now a few things to point out when it comes to both secant and cosecant. The domain, I can construct an equation saying x is everything except x can't be the equation pi halves plus pi k. Now looking at this graph, there's my first value, pi halves. Now if I add plus pi k, that's going to bring it to this value here, and another distance pi, etc., etc. So the idea here is that I'm excluding every single value that has a distance of pi, starting with that pi halves, and it can even go in the negative direction. My range, it's between the values of greater than 1 and less than -1, or another way of looking at it, it's -infinity to -1 union from 1 to positive infinity. Now even taking a look at that, if I were to take this and smush it onto the number line here, that's -infinity to -1 union 1 to positive infinity. And basically the rest of this is very similar to what it would normally be for sine and cosine. It has a period of 2 pi. They're both even and odd respectively to their graphs, and it's continuous and smooth on its domain. So now let's actually practice graphing one of these. Now when we do graph it, the easiest thing to do is pretend like it's that parent function that we associate it with. So for example, secant, I know it associates itself with cosine, and so that's why I'm going to put cosine in these parentheses. And so the parent graph for cosine looks something like this, and I'm able to construct an image that looks like that. And then because we know that the amplitude is the distance from the center line to the highest value, or the maximum minimum, well, we didn't really have that image with the secant, right? I mean, it's like these parabolic things. What is the maximum there? There is none. Or what is the minimum? There is none. So instead, we're going to use the amplitude. We know that it's 2. The only reason why I'm saying that 2 is because I need that to graph it, but officially there is no amplitude for secant or cosecant. The only thing that has an actual amplitude is sine and cosine. My period, it's still 2 pi over b, and my phase shift or horizontal shift, that's going to be -c over b. So now I need to take this information and I need to put it on my graph. Now we said that I can take whatever's in the inside of my graph and I could put that between 0 and my natural period. Now my natural period for secant, since it relates to cosine, is 2 pi. So now trying to get this by itself, I'm going to add pi halves to everything. And so I'm going to get pi halves is less than or equal to theta, which is less than or equal to 5 pi halves. Now creating my value box, this is going to be pi halves, this is going to be 5 pi halves. if I add the ends and divide by 2, so pi halves plus 5 pi halves all over 2, that's going to be 6 pi halves over 2, so that's going to be 3 pi halves. Now if I do this one, add the ends, divide by 2, you're going to get 2 pi halves. If I do this one, add the ends, divide by 2, you're going to get 4 pi halves. So we have pi halves, 2 pi halves, 3 pi halves, 4 pi halves, and 5 pi halves. Now, sketching that cosine graph, we know the amplitude is 2. We know it's going to cross the center line. We know it's going to go below, cross back at the center line, and go back above. But that's where graphing the quote-unquote cosine graph stops. We're no longer going to graph that graph like that anymore. Now what I want to do is wherever it crosses the center line, which was here and here, I draw asymptotes. Then at the peaks, I'm going to draw those parabola-shaped things, those parabolic shapes. And there's my secant graph. So what I did here is I set it up like I would sine or cosine. And so that's why for this I said, hey, let's pretend like it's cosine. I did the parent graph, the supposed amplitude, what the period is, and the phase shift, etc. I went through and I did the value box, and I took that information and I was able to label my graph. And sketching the outline of what my cosine graph would look like, I graphed those points without drawing the line, which would be step 2. Then step 3, where the graph crosses the center line, I drew asymptotes. So since it crossed the center line here and here, I drew in those asymptotes. And then step 4, at the peaks, so at here, here, and here, I drew in those parabolic-like shapes, and I was able to construct my graph. Looking at this one. So because it's cosecant, I'm going to pretend that it's sine. I know that my sine graph starts here, goes up, goes down, goes below, goes back. My amplitude is 1, but I do have a negative here. So because of that negative, there's going to be a reflection. And so my sine parent graph is going to have that type of image because of that reflection. Remember, it's cosecant. There is no official amplitude. It's none. But I consider it the quote-unquote 1 because it allows me to graph it easier. There's a vertical shift. It's shifting up 3. My period, 2 pi over b. So that's going to give me 4 pi. And then there's no vertical shift. I'm sorry, horizontal shift or phase shift. So my horizontal shift is going to be 0. So now I take whatever's on the inside of my graph, I put that between 0 and my natural period, which is 2 pi, multiply everything by 2. So I get 0 is less than or equal to theta, which is less than or equal to 4 pi. So now I can construct that value box. 0 is here, 4 pi is here. Add the ends, divide by 2. Add the ends, divide by 2. Add the ends, divide by 2. So now going through and constructing this and piecing everything together, I know I have a vertical shift. It's going to shift up 3. There's no horizontal shift. It still starts at 0, so drawing the image. Now remember, we had that negative, and so that's why I drew it with the reflection over the x-axis. So now I did 1. I sketched the outline. I'm not going to draw the sketch of the graph, which is going to be step 2. Now step 3, it says where the graph crosses the center line, draw asymptotes. So I'm going to draw asymptotes here, here, and here. And then at the peaks, draw the parabolas. And we have our cosecant graph. Now this does conclude the lesson here, so if you guys do have any other questions, please leave them in the comments.